So a large number of the students said that, okay, this was interesting, they enjoyed it, they saw some connections, and they understood what was going on. But what's really interesting is the comparison between the two different groups. So this is from page 7. Quote, across both the quadrilateral and triangle lessons, and compared to their peers in the CS-only implementations, more students in the cross-context implementations found the lessons interesting, saw connections to their mathematics classes, and understood the programming, end quote. A little bit further down on page 7, quote, this suggests that encountering CS and mathematics content in both the classroom and the computer lab helps students more effectively see the connections, end quote. So in other words, instead of learning it all in one space where you're learning both computer science and mathematics at the same time, instead of combining it so that you are learning mathematics in a CS class and learning CS in a mathematics class, they're better able to see the different connections between that approach than the other approach where it is just a purely integrated class or a purely integrated lesson. This has a lot of implications for the field if we can find that this is true in other contexts. Again, this is a single district in a rural setting, so maybe this finding wouldn't translate to other classes. But one thing that I don't really understand and know based off of what I was reading, maybe I just missed it somewhere, is whether or not they're receiving twice as much instruction on the content, like when they were doing the mathematics class and the CS class, so it would kind of twice as much the reinforcement, or were they receiving the exact same amount of instruction in the integrated class where it was not cross-context, spread between the two different classes. Like if they spent 30 minutes in math, 30 minutes in CS learning this thing, compared to the other group that spent 60 minutes in class learning mathematics and CS at the same time, maybe then that is a valid comparison. But if it's 30, 30, 30 overall, then I don't know about that. It would make sense why the other students would be able to have a better understanding of it because they spent twice as much time in it than a purely integrated class alone instead of cross-context. If you want to listen to the full episode that this excerpt is from, make sure you check out episode 184 of the CSK8 podcast, which is titled Rethinking Integrated Computer Science Instruction.